Yes, you can hear me. Nice. It's such a pleasure to stand here just to talk after Venkat was on stage. No pressure at all. Anyway, I'm going to talk about a completely different topic. It's a security topic, and I'm glad that so many people are here in the room because apparently security is a thing nowadays. But let's not talk too much about security as in securing your Java application, but let's look a little beyond that. Let's go to containers. Who uses containers? Who uses specifically Docker containers? Who hates containers? That's a few. Gotcha. I gotcha. No judgment. Not out loud, at least. But let's talk about what is a container. If you look at what a container is, it's something like a receptacle for holding goods, or something that holds something else, if you look at Wikipedia. And we try to mimic things and terms within software in the same way as we have things in the real world. But if you look at containers in the real world, containers can mean different things. This is a container holding my beer. Hopefully afterwards it's still cold and it has enough bubbles in it, because that would be disgusting. Or something like this, your airtight container to put your food in, to preserve it, and to make sure that the flavors are there when you store it. But more or less, if we talk about containers, people always see these containers, like shipping containers. And all of them are there for specific reasons. All of them are there to hold specific goods. But you need to use the right container, right? It doesn't make sense to put my beer in an airtight container. Well, it may work. But putting my beer in a shipping container without the proper container doesn't really make sense. So every container has a specific purpose. Every container is there for a specific reason, and you have to use the right container for the right purpose. Okay, so far so good. But if we look at containers in the real world, we see containers as a boundary between the outside world that minimizes the amount of influence to whatever is inside. Correct? Well, a lot of people think that is the same with software containers. Well, let me tell you something, it is not. If people think, and a lot of people think that way or thought that way, is, hey, we have an old Java application, let's bump it up, let's lift it and shift it, put it in a container, and by default we're safe now because we now have a boundary with the outside world. Guess what? You were wrong. Because this is only a container, this is a protection against the outside world. Basically, from the inside to the outside, there is no traffic or no influence whatsoever. But if we put our Java application in a container, it's basically a container with holes in it, because we need to have that Java application have a connection with other things like databases. The user, maybe, that might be interesting, or else it would be there in a vacuum. Well, then it's safe. But does it have any purpose? Not anymore. So containers in Java are not, or containers in software technology are not the same as containers in real life world. However, every time you see a Docker post, people use that shipping container. It is not the same. Lifting and shifting your application, put it in a Docker container, and thinking you are safe is not the case. And that is what we're going to talk about today. Oh, by the way, this is me. This is the boring slide. I am a staff developer advocate. I don't know. I never know what a staff was. Like, I have to stand like this with a staff. Developer advocate basically means I was an engineer and now I email. Java champion, virtual jug, NL jug. Well, I do some stuff in the community, but that's not important. We need to talk about that container stuff and why, as software developers, we need to take care of that as well. Because nowadays, if we talk about Docker, just to make that easier, the Docker file is part of your code repository. And trust me, you and your team that maintain that tiny microservice or that landscape of microservices are also responsible for that Docker file, apparently. And why is Docker my go-to thing? Because, well, at this point, there's 1 billion weekly downloads of Docker containers, of Docker images. So it is significant. It is a de facto standard. And yes, there are other players on the ground. But still, let's just take one as an example, and we can transpose all the tips I will give you to the other ones as well. Truth to be told, some of them are better than Docker, but I'll leave it up to them. There is a great stand here with the people with red fedoras that also do containers. I think they do a tiny better way. Anyway, it boils down to this. I'm going to you end up with 5 tips not to fail your security within a Docker container, specifically for Java developers. Of course, most of them you can pick up. You could say to a Node developer, do the same, but something like that. First of all, choose the right Docker base image for your Java application. And you might say, yeah, duh. But it's just like that container that I told you about in the beginning. Picking the right container is essential. Because what is the first thing most people do? What is the first line in a Docker image? Who can tell me that? Hopefully from scratch. But most people know, no, from Ubuntu, fine. Which tag? I don't know, latest. Hey, if it looks stupid but it works, it is still stupid. Anyway, what I did, and it's already research from 2019, I downloaded at that point the 10 most commonly used Docker images from Docker Hub that were used as base images and scanned them for vulnerabilities. And to my surprise, just say my manager is a Node.js developer. That was a nice debate. Anyway, you see all these 10 freely usable Docker images were vulnerable or had vulnerabilities. And if you boil down to that, like saying, Node has the most vulnerability. If you look at that image, it's not so much Node that is the problem. No, it is that problem is, where is the Node image based on? The Node image, latest, these were all latest images. Node image, by default, is based on Debian. Full Debian, not Debian Slim, not Debian, at that point, Debian Jessie, which was kind of vulnerable. That means that whole operating system comes back into your application, and you're building that nitty-bit tiny microservice. Do you need a full operating system, do you think? A full operating system comes with a bunch of binaries. All these binaries are there for grabs. I won't say that they're directly vulnerable, as in from the outside I can access the binary. No, but if I'm for some way in an application, I can use it in a chain of attacks. Because if you look at security problems, it's most of the time a chain of attacks. As in, I can do this, that connects to that connects to that. Oh, and there, now I can get that binary that is vulnerable and do remote code execution. Ta-da! It's not as simple as one hit, one kill. I wish. But the thing is, if you bring in a Node image like this, it's not Node, it's the Debian image. But do you know what you're bringing into? Who takes care of that in their day-to-day Docker images? Exactly 4 people. So you're in the right room. So if we transpose that back to vulnerabilities in operating system images, you see that picking, in this case, a Java image or a Node image based on another operating system can already boil down to less vulnerabilities. Because just like dependencies in your application, you're depending on something. And Debian has far more stuff in it than Ubuntu or Alpine. Not saying that Alpine is the best choice because of, because of the libraries that it ships with, but just for a matter of speaking, it depends on which image you're downloading and which image you put in that from thing in your Docker image. That gives you the amount of attack factors. If I transpose that back to Java, this is the Eclipse Xamarin 17 JDK. The default one, without the latest image, or the latest tag, is bound to Ubuntu. And you see the different versions of Ubuntu at this time. This was a snapshot from September 2022. 21 and 18 vulnerabilities. And I didn't slice them down into critical or minimum or low, whatever. But if I chose a specific CentOS thing, I had over 1,000. So it makes sense to do some research on what kind of image you're using. Not just using the latest image. Maybe a specific tag. Maybe even boil down to the specific hash so you have deterministic builds. And you can say, okay, sure. But what could possibly go wrong with a Docker container image, right? Well, you yourself can maybe use something from the operating system, like calling a binary, or one of your libraries might call a binary. Let me give you something. This is a very old one. It's a problem of improper input validation in ImageMagick. And ImageMagick is a tool available in Debian or in Linux to do some image magicry, resizing, for instance. It was so tragic that they had a specific name called Image Tragic, which I think is funny. But it already boils back to 2016. And, well, let me show you what it actually was. I'm running a very old Node Docker container. Node version 6.1. Yes, it's that old. But the thing is, I am using ImageMagick in this. And we just made a very tiny application. Let me larger. And what it does is it can resize pictures. So I can choose a file. I can go to, just use this old picture of mine. If I resize this, under the hood, it uses ImageMagick to resize this picture from the size it was to a format that is good for Twitter. Nice tool, I thought. However, it uses ImageMagick, what I told you. But what the thing is, you think you might open a JPEG, but it's not always the case. Let me show you. Let me enlarge this. So, I have a bunch of images over here. Hope you can read it. Let me make it large. RC1, RC2, and RC3. Let's go to RCE1. So let's cut RCE1.jpg. This is, for ImageMagick, a valid JPEG file. Basically, it doesn't know the difference between SVGs and JPEGs, and it just accepts everything. But also, it does not do any input validation on that file. So it says, like, OK, let's create a view box, which is possible in SVG. SVG is basically just describing how an image should look, or that is a possibility for an SVG. Just use an URL, and that URL points to something oops.jpg, which does not exist, but this pipe comes in. And then I say, touch RCE1. In other words, I'm trying to create a file. Just for the matter of perspective, I logged into this container, and RCE.1 does not yet exist. So if I upload this image, so I said, yes, let's do this again, choose this image, RCE1, and resize it, you won't get an image back because there is no image. However, I was able to do arbitrary code execution, and now there's a file that exists here. That means if I can create a file, I can create a file with content. I can create a script. In the second attempt, maybe tomorrow, come back and execute that script. Or even worse, I can do a reverse shell attack. This is somewhere on the internet. I just listen to a port, and I say to your application, connect to my port 9000, and depending on how many or what the default user is, I do have possession of your machine. This is horrible, and this because I'm using a library that doesn't do proper sanitization of the input, and I just blindly use it because I thought, well, hey, it's there for Debian, I can use it. Updating just the image to a newer Node image or to a newer Debian image in this case would solve this because it's not my problem. I'm actually just using something, but the library or the binaries problem that comes with the library. And you might say, okay, but I'm not using anything from Linux or from the operating system. But are you sure that every library that you have in is not using anything from the operating system? Or there is no case at all? Who is absolutely 100% sure of their application is not using any binary that is on the operating system? Exactly, you don't. So it's a good case to look at this. So yes, things can go wrong. Secondly, only use what you need. And that sounds like the same, right? Use the base image that you need, but only use what you need. But do you need the whole base image as you're downloading it? Just saying, if I look on the internet and I do the very naive way of creating a Docker image for a Spring Boot application, I stumble on something like this. Tell me what is wrong with this. The answer is everything. Everything is wrong with this. Because I'm using OpenJDK 17. First of all, the OpenJDK images are deprecated, but just decide that. I'm creating a directory. I'm copying my whole source code into that container. I'm setting a work there, and then I'm using Maven, because that's shipped to that container, to package it and to run Spring Boot. So basically, I have my source code the full JDK, Maven, and the artifact that I built to actually get executed. What is the only thing that I need? A runtime and a binary, exactly. Actually, if I can get into this application, I might be able to change your source code. There is a build tool for me. There is the full JDK. Rebuild it, and you said, my container was just down for a second. Oh, but it's there again. But it does something completely different. So you give somebody who is in, and the case is, okay, you need to get in, but somebody who is in, you give them all the tools there. Like, here, you got it. So good luck. So what can we do? Oh, yeah, by the way, this is over a gigabyte. Because it ships everything. But hey, if it looks stupid but it works, ship it, right? First of all, we can use multi-stage builds. Who uses multi-stage builds in Docker? Thank you, appreciate that. You can have a distinguishment between build image and a production image. If you want to build using a Docker file, perfectly fine. But separate the two. For instance, over here what I did. I have two stages. The first stage is I'm using OpenJDK 17 to build my image, and then I have the package. And then I'm using a very small image, in this case, Eclipse Xamarin 17 Java runtime environment, because they supply it still for me. Alpine, that does work on my Intel machine, but not my Mac in this case, because something ARM. I just copy the artifact, and I run java -jar. That is all I need to run it. And yes, you might say, like, I need other tools. Yeah, sure, you can copy these tools. You don't need the full JDK for that. Unless you want to, sure, then you need it. But in most cases, I need to ship a tiny microservice or tiny service to the thing. You just need the artifact and a runtime. Oh, by the way, this was 270 megabytes. So spinning something up and down, it's a gigabyte big or 200 megabyte, that's already a huge difference for scaling. Next thing is, these two steps are completely separate from each other. If you look at the history of a Docker file, of the end Docker file, so the one that's based on Eclipse Xamarin, you won't see anything that's happened on the earlier stage. So if, for instance, I needed to supply something with specific username and password because I need that to connect to a specific repository, I can freely use it in my build stage because that will be thrown away. The only thing that is left is my final stage. So if I need to have secrets in there, and of course you should pass secrets out of containers, but say you need to, and this is the easiest, sure, you can do whatever you want over there, or whatever tooling you need over there in that build stage. That get all thrown away, and you only end up with the final image. And then people would say, yes, sure, but you said Java 17 and a JRE? Well, from Java 11, actually, most JDKs or most JDK vendors don't supply a Java runtime environment anymore. And the reason for that is because we use JLink, or we can use JLink. Some providers, like Eclipse Xamarin or the folks at Azul that create containers, might pre-build a container for you with a Java runtime environment. But you can make it even smaller. And guess what? What you don't need and you move that out cannot harm you. That's basic principle of security. If it's not there, it cannot harm you. So what you can do is use JLink to create your specific JVM or your specific runtime, specifically for your application only. So something like this, and this is a partially Docker file. Like, hey, I need a bunch of modules, and then I say, yeah, strip all the debug information. Compress 2 will says I accept zipped files, so basically jars. I don't want headers, I don't want the management page, etc., and I output it to my JRE. But then you're like, okay, how do I get all of these modules for my application? Because we all know Spring Boot is fantastic, but it's also weird. And how it stores your libraries in what kind of way. So JDEPS comes into play to do that for you. And it took me a few hours to figure out how that works for a Spring Boot application because it's not straightforward. Ta-da! Well, let's focus into the point which is actually important. It's this. And there are multiple ways of doing this. Multiple ways. First thing I do is I have the jar, and I unpack the jar, because I want to know where these libraries are, because these libraries are packed in that jar. I'm using JDEPS, and I'm pointing JDEPS to the boot dash inf slash lib slash star, basically there where all my libraries are there. And my target is, of course, my jar file that I'm gonna use. In this way, JDEPS will come up with all the modules I need, and specifically for this Spring Boot application, and I'm storing this in deps.inf, or info. Then in the second step, I'm using JLink again, and I'm just reading that deps.info to get the smallest possible JVM, or the smallest possible runtime I need for this specific application. In the next step, I can use, in this case, I use the Debian stable slim. I copy, basically, the JDK I created and the jar file, and just do it java -jar. This means that if you need to use tooling like Flight Recorder or something like that, you can package that in this way. With JLink, you now have all the tools you need, and yes, you need to do a little research how this works, but all of the tools you need to make the slimmest possible image. And yes, I used the Debian stable in this case, but I would suggest that you use the slimmest image that you can find. Or even better, that you, in your company, create an image that you maintain that you can use. As in, there is a platform team maybe, or something that has an image that they maintain that, you can use it, and that image is as small as possible, because if you own the image, you exactly know what's in there. If you don't know the image, just like here, Debian stable today can be a complete Debian stable slim tomorrow, because this is a rolling tag. Think about that. So yes, this is the whole thing. If you want to, I will publish the slides anyway. If you want to know more about JDEPS and JLink and how to create a minimum JVM, go to Anna's talk tomorrow. She will do a Java Performance Toolbox lookout to see what kind of tools are there and how you can use them. And I went to that talk and she knows. So if you want to know more about that, go there. Who knows what the least privilege principle is? Who've heard of the least privilege principle? Basically says, like, if I need to do something, I only need the access or the credentials for that and only that. Nothing more, nothing less. I need to do my work, and I need exactly these credentials that I need. Think about it. If you're going to the hospital and you're having some weird disease, do you want the whole hospital to know it, or just the doctor that's treating you? Probably the last one. That's what we call least privilege principle. Not all the doctors need to know that. Maybe they do, depending on how secure the system is, but you get me. Oh yeah, we've got this thing. Just saying we're using this application. What is the default user that my java./jar is running on? Who says root? Who says I have no clue? Who says I don't care? Thank you, at least everybody cares. I'm happy, but yeah, it's root. By default, every Java container, or every Docker container, runs as root if you don't specify the specific user. So, focusing on this, we can solve that. And this is an Alpine image. So the commands might look a little different if you do this on Debian or any other Linux thing. And let's focus on the lines that came through. So what I did here, and again, this is an example, not saying this is the only example, but what I'm doing here, I'm creating a system user with no shell access, with no home directory, etc., etc. And on the third line, I'm basically saying, okay, I need ownership of that project folder. Why? Because I know this application also stores things in that, temporary in that thing. Hey, I've got a good reason for that. You can say I do it differently, but I say, okay, this user only owns the project folder I just created. So a system user without, basically headless, without any specific access or specific shell access, I create that and I give ownership to that project folder. Then the third line is the most important line, because you can do all the preparation, but if you don't call that user, it will still run as root. So the third yellow line, I'm calling that user I just created, and from that point on, everything will be executed as that specific user. And now I know that if I am in, I can only access a specific part of that system, a specific part of that container. So that also means the chances that I can call other binaries, for instance, might be slimmer. Or I can do other things outside of that project folder are very slim. think of it as security needs to be layers. Yes, you need to make sure that not the stuff is in that you don't need, but also like, hey, limit the usage of that, because if it's root, then we can do other things, install scripts or something like that. And there's an easy way to do that. Just add a user. By the way, some containers come with a specific user. I know that the node image, for instance, comes with a more privileged user, but you still need to call that. If you don't use that, you still need to call user then and then that specific user if it comes pre-prepared. So beware of that. Then, scan your Docker image and your Java applications during development. Like, it's nice to find out about issues during development and not like, yeah, we test in production. It's fine. We asked people in our State of Open Source Security, when do you scan your Docker images for operating system vulnerabilities? And 50% basically says, we don't, which is kind of scary. So what you can do, and of course I'm using my tooling for the company I work for, but there are multiple tools that can use this. You can pull an image and you can scan it and to see if there are vulnerabilities in that image before you actually use it. And this I can do on my local machine. And you will get something like, these are the vulnerabilities. And then you can assess if these vulnerabilities are harmful for you or not, because that is context specific. It can be something that can harm you. It can be something like, yeah, this is an internal application, I don't care about this one. But you can only say that if you have the information. If you don't have the information, like, yeah, it looks fine to me, ship it, then you might get bitten in the butt. You can absolutely do the same for your own created images. So you create an image based on a based image, and if you call that specific image with that specific tag and give it in this case, the Docker file, we can also provide you with possible remediation advice, as in, hey, you're using base image X, maybe go to base image Y that is newer, has lesser vulnerabilities. And I will show you that in a second. Well, actually, I will show you that now. I have an application here, and this one runs on the internet, this one runs on a local host. You see, it's an application, it's an old Java application based on struts. Why would you do that? Well, I will show you in a second, because this was a typically lift and shift. This runs on a local host, as you can see, and it's basically is running in a Docker container. The only thing is, let me just show you the Docker file. You will see what's going on here. Let me see where it is. It's here. This is a Docker file. So I'm using Maven JDK 8 to build it, blah, 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 copy a bunch of stuff. And then I'm using this is a multi-stage build. This is my second stage. This is a old-fashioned WAR file comes out of this. And I need a server to build it. In this case, Tomcat. So I'm using Tomcat 8.5.21. So who can tell me, just to show that you paid attention, what's wrong with this? What user does it run on? Root. Okay, keep that in mind. So I forgot. Oh, damn. But also, Tomcat 8.5.21 is kind of old. And I built it like 4 years ago, and it still works, so don't touch it. That's how we work in a bank, right? Or at the government. Works. Nobody cares about it anymore. Don't touch it. However, if we look at this application, it has a problem. And that's a problem in the Docker file, an arbitrary code execution, because Tomcat comes with Tomcat. And it was possible to upload JSP files to the server via a specially crafted request. And this JSP could then be requested, and any code it contained would be executed by the server. Isn't that nice? So, going to my favorite database, the exploit database. And allow all cookies, of course. I love cookies. Anyway, this is a Python script. And basically what that Python script does is it creates that specially crafted request, and it creates two payloads. The first payload is a JSP file with this. Simply an output println to see if it works. If it turns up with a page with all A's, it's like, hey, I can inject it. Yes, score, it's vulnerable. Because then I can continue with the second step of my attack, which is basically a JSP file that contains a form. And that form contains a text box. and a submit button. And every time I hit the submit button, the content of the text box goes here. I create a runtime.getRuntime, and then a buffered reader to read all the stuff and output it on the lines below. So basically, I'm creating myself a web shell. Let's see if this works. So we are here. POC.jsp does not yet exist. PWN.jsp does not yet exist on the server, and it's all on 8080, basically the Docker container that I'm running now. So let's just try. I load that application. I already have it preloaded here. So let's check and see what it does. And it says, it's vulnerable. So that means that first thing should be there. And ta-da, we've got all A's. So that means it can accept from the outside, it can accept incoming JSP files, and it executes it. Nice. So now I can go to my second step of my attack. And of course, this is just an open proof of concept. So you can try it out yourself by saying PWN, and it says uploading web shell. So let's try that. Look over here. And cool. Well, we already know this, but who am I? I am root. So I can do whatever I want. I now have a web page in front of me, and I can distribute it to anyone that has root access and can do anything I want in this container. Install my Bitcoin miner, for instance. And you're running on AWS. Good luck with your bill next month. No, but you see, I'm not attacking your application anymore. I'm not looking at your container. Because it's regardless of whatever you put in there, you're based on a Tomcat container. And if I would have, I could have known, because I scanned it here on my local machine, somewhere. I guess, I hope. I thought I scanned it. Yes, here. So it has a bunch of application errors. Well, let me just enlarge this a bit so you can actually read it. And it says to me over here, and I will zoom in for you, hey, you're using Tomcat 8.5.21 that has 735 vulnerabilities, and 70 of them are critical. And you could also update to a minor version 88, and that changes pretty much every week, that has 22 vulnerabilities and 0 criticals. So doing that, only changing to a newer base image, solves the whole problem for this, because that Tomcat image is changed. So it makes sense that sometimes you can just rebuild your Docker image with a newer base image to get rid of vulnerabilities and not even touching your application. Talking about your application, by the way, you should scan that as well, because of course there is a bunch of things going wrong over there. Because if this is the binary that I put into production in that Docker image, how much of that binary do you think is your code? The code you wrote. It's probably this. And who does code reviews? Okay, I don't see all hands. That means the rest of you does pair programming. That is great. But at least we take care of that code. But that's the tiny purple bit in the middle. What about the yellow stuff? Do we take care of that? Do you have ways to get into these dependencies that you pull in that might, again, connect to binaries that are in your Docker image? Do you have any clue how many binaries there are in your thing? Who's using Spring Boot? Cool. I did a research, I think it was 2 or 3 years ago. I just had the initializer Spring Boot. I created one endpoint that says hello world, and I counted the amount of files, or I counted the amount of lines that it created for me. I think it was 4 lines that I created, and over 400,000 lines that was created by Spring Boot. And I have no clue what that is, because all these things are there. And you can't say like, yeah, but not all stuff is connected. Not all stuff there is a path directly to it. Sure, but there's something like reflection, and there's something like, how do you call it? Expression languages, which every class that is there on the class path could technically be loaded into memory. So modularizing your Java already to smaller things help, because then some of your dependencies might not even work that you're not using. But cutting that down makes sense. But also making sure that you are up to date with these kind of things. For instance, same application. Application runs on Heroku. You see? Heroku. And actually runs. But this is based on Apache struts. Who heard of the Equifax hack in 2017? We're going to replay this, exactly. Some might have seen it because I've used it before, but just for the sake of argument, I'm not doing a lot of stuff. I'm just using Apache struts. So doing that, I can use Apache struts to do a specific curl request using a specific header. And this time, it's a content type. A content type which we all know, right? Who understands this content type? It's an invalid content type. And because this is invalid, it goes into an exceptional flow, and in that exceptional flow, you are allowed to utilize the expression language in struts, which is OGNL, the Object Graph Navigational Language. And what I can do with that is I can call certain methods on certain objects that are in memory, or I can just create a new process builder. Give it the bash, and give that bash an arbitrary command. So doing that, I can do something like, let me just try that. And let me use this one. So what I'm doing now, I'm using that header, and I make a substitution. The word command goes out, the word env goes in, and I point it to localhost 8. No, let's do a localhost because it's far more interesting to do it on Heroku. And basically, I'm asking for the environment variables. And as you can see, at least partially, I have the environment variables here. So that means I can execute code. And again, I can, depending on what user you're at in your container, or in this case, Heroku is just a container. I might be able to create files with content, do a reverse shell attack, or whatever I want. And I can go on and on and on. This just because I'm using a library that is outdated and was already updated. So then I can connect certain things together. Whatever is available to me from that base image, I can now connect together with this because you have an application vulnerability. But if you slim down your container, it's a lesser threat factor. If I would have done this in such a way that I'm not root, except, but you get the point, right? So everything connects into everything, and that's the whole point. If I would have scanned this, it would have known that this library was vulnerable, and it could have updated to a newer version. Bottom line. We see that most problems of these dependencies are in the transitive dependencies, because you probably have some Spring Boot starters in your application, and the rest you have no clue, but that brings in automatically. So, yes. What could possibly go wrong in my app? I just showed you. Last thing. I started with the lifting and shifting paradigm. But you need to build your image in such a way, and this sounds like an open door. But build your image to rebuild at any time. So that means at any time I should be able to get rid of an image. So if I just get my Java image and put it in a container, that is great, but I probably don't have one image. I might have 3 of the same images running. They're probably using Kubernetes or some other stuff. Maybe some people are still on Docker Swarm, I don't know, or any other technology, doesn't matter. But say I have all logging in place and I can see what's happening in a certain thing, and I see a weird behavior in container 3, and that gives me an alert, and might be, okay, there might be somebody in there. The first thing I want to do is demolish it right away, if I can do, or even automatically demolish it, because certain amount of 500s or a certain spike in CPU usage, you can do all sorts of things. You can demolish it and rebuild it, and hopefully rebuild it even with a newer image if you already have that available. So that depends on how you do it, but you need to be able to do that. That means if you lift and shift the old-fashioned way, people still think is doable, you have to make sure that all things that are persistent are not part of your container. So using an H2 database, as I did, it's not good. No, but simply, I mean, if you have logging in your container, because I just packed it up and put it in a Docker container, if I have caching in my Docker container, if I have even my database in my Docker container, no. Make sure that you create your application, and again, it sounds like an open door, but for many parties that we consult for, this is still a problem. Make sure that this part is outside of your container. It's somewhere stored outside, so I can demolish that container at any certain point in time, and I don't lose my critical data for my customers. But if you don't build like that, and you just had the old-fashioned monolith, and you put it in a container, and now we're done, now we're happy, then you might get bitten in the butt again. Note that 44% of Docker image vulnerabilities can be fixed by just a newer base image. So scanning your image on a regular base makes sense, and rebuilding it makes sense, because that base image gets newer. And you maybe want to argue with your team if you want to have a specific base image or you want to have a rolling image. As in, using the latest, hey, we can get into that argument. I would say use a specific image with a specific hash, so you have deterministic builds, you have full control over it. But I know some people act differently or want to act differently, which is fine. How do you find out about vulnerabilities you deployed in deployed containers? We asked the same people in that open source security summit that we did. 45% said, I probably won't, which is scary. We also find out that 20% of Docker image vulnerability can be fixed by just rebuilding that same image, because you're using either a latest tag or a rolling tag. And building Ubuntu latest now versus Ubuntu latest next week is probably different because they upgrade. So doing that, even though you're not touching your application, and yes, I'm repeating myself, is a good thing, because a lot of people do this in containers. You shouldn't, I think. But if you do this, please rebuild it daily or something, and just deploy it again. Oh yeah, and if you rebuild it, you might want to act -- no cache in it, because you get bitten in the butt again. All right, I've got a few minutes left, so let's ramp it up to the five things that I want to show you. First of all, choose the right base image. Do research, as in what base images are there available, and what base image do I need to build my stuff. So preferably, you use a base image that you created from scratch, or your company owns. I advise my clients not to use a public base image. Use a base image that one of your teams is creating, and they're maintaining it, and they're focusing on that image, so you can safely use it. If not, do research and do not just blindly take an image because you don't know what's in it. Use only what you need. A Java runtime environment over a JDK, or even preferably, create a runtime yourself using JLink and JDEPs. So you have the smallest image, easier to deploy, easier to scale, easy to elastically scale or revive if needed, but also safer, because what you don't have cannot bite you. Obvious. But still, please do not run as root, ever, 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 ever. So create your own user and specifically call that user. If you don't call that user and you create all the stuff, sorry, you're still doomed. Scan your applications and images. I just showed you that with an easy scan, I could find out that I'm using an outdated image and I should be using to a newer base image. Sure, you can do that with your private images as well. And first and foremost, build to rebuild. Don't lift and shift. Look at your architecture that you can actually create an image that is built for a containerized landscape. And still, a lot of people, specifically people higher up that have no clue what containers are, just put it in a container, unfortunately. I thought we were done with that, but we're not. Anyway, these are just 5 tips. These are the 5, what I think, most important tips if you think from a security perspective. And think about it, everything you do better now than tomorrow is already a win. You don't have to do everything at once. But if you look at it, and if there's one thing that can help you, like, we have to look at that one. That's already a win. We cannot solve all security issues at once. Just try to be a little better than tomorrow or than yesterday. If you want to have more, we created a 10 best practices sheet. Again, I will publish the slides with the URLs. That goes into other things like don't use old Java 8 modules, for instance. If you want to know more about performance tuning on containers, I would suggest that you go to this talk by Bruno Borges from Microsoft. It says performance tuning for Java and Kubernetes, but he starts with containers and looking at containers and how you should tune your garbage collector, for instance, that you should put memory boundaries in because things go sideways and you probably have no clue what you're doing if you put the defaults in just. And it sounds easy, but it's very entertaining. Anyway, I want to leave you with that. If you have any questions, of course, I'm happy to answer. If you're like, hey, I've got 5 minutes left, let's get something to drink, you're absolutely fine. So I want to thank you.
To respond to that.
You don't know how to respond to that. That's cool. You're welcome. Anyway, this is what I had to tell. Thank you for being here, and I hope it was useful. Are there any questions? One. What about build packs? Build packs are great. You can use build packs, but do you know what that build pack maintains? What the content of that build pack is? You don't know what it's really. So yes, build packs are great. Build packs, more or less, are slimmer versions or distroless versions are also great. But still you have stuff to do, as in, do you know if there's a specific privileged user? Nope. Do you know what's... Sorry? Paquito, yeah, sure, there are, but you need to know, and just not... The thing is, don't use it blindly. Same is with... I have the same question with tools like GIP and that. It's cool, but it depends on, again, you can do GIP, for instance, with a specific base image, and if you know what that base image is, it's totally fine. But also that changes over time. It used to be a distroless build pack, if I'm not mistaken, and now it is something else. So it doesn't... Yes, these are good. Yes, you can use them, definitely use them, if that slims down your image. But be aware of what you're using, and be conscious. And please keep things like scanning and redoing it over time. All right. If there are no further questions, I'll let you go. Thank you.